Alright, now we're trying to determine the maximum amount of fuel that we can load with the airplane situated as the problem. So I'm going to go ahead and start with laying out the WAM, weight, times arm equals moment. And in this case, the moment is given and divided by 1,000, so I'm going to write that down just so I don't forget it. So we have aircraft, empty weight is 1,350, and the moment, 51.5. Then we have pilot and passenger. Pilot, so I'm going to solve front seat, weight, 340. Rear seat, 310. Baggage, 45. And then oil, 8 quarts. So remember, oil is 7.5 pounds per gallon. 8 quarts equals 2 gallons, and 2 gallons times 7.5 equals 15 pounds. So oil, we have 15 pounds. Alright, so now we're going to go ahead and determine the moment for each of these. So we have front seat is 340 pounds. So 350, 340 is going to be right about here. And then where those intersect, and that's going to be 11, 12, 11, 12, about 13. About 13, just more than 12. So there's 12.5. So about around 12.6. So front seat moments, 12.6. Rear seat, 310 pounds. So 310. Where they intersect. And that's going to be 21, 22, 22.5, about 22.6. Baggage, 45 pounds. And that's going to be about slightly more than 4, so about 4.2. And then we're given that 8 quarts of oil equals about 15 pounds at negative 0.02 moment. So negative 0.2. So before we do fuel, I kind of want to get a level set of where we're at as far as center of gravity and moment for what we have already. So I'm going to go ahead and go into weight and balance, and we have weight and moment information, so that's the function we're going to use. The aircraft is 1350. Moment is 51.5. Reduction factor 1. Next one is 340 pounds. Moment is 12.6. Next one is weight is 310. Moment is 22.6. Next one, 45 for the baggage. And that's about 4.2 moment. And then next one for the oil, weight 15. Moment is 0.2 negative. So now we have a new total weight of 2060 and a moment 90.7. So just to see where we're at on the chart, I'm going to go down and for a moment 90.7, I'm going to draw a line up. It's going to be about in line here, and the max gross looks like it's about 2,300. So 2,300 minus the weight we have already. £240. And remember, 1 gallon equals 6 pounds. So if we were able to use all of the 240 pounds for fuel, it would be 240 divided by 6 would be 40 gallons. So now what we need to do is we need to determine if we can add 40 gallons and still be within limits. So after we've determined the new center of gravity, we can use this as the starting point, and we can say we're going to add 240 pounds for fuel. So we're coming back over here, 240 pounds. We need to determine the moment of that 240 pounds. So we're about 10, 11, 12. Alright, now we're going to rework a new weight and moment problem. So we're going to go weight and balance, down to the moment. Now because we've already calculated all of these, and that gave us the new weight and moment, we don't have to do the entire recalculation again. We can basically use the new weight and moment as the starting point and then just add for the fuel. So we're going to start with the new weight and moment. Weight is 2060. Enter. Moment 90.7. Enter. Reduction factor 1. Now we're going to add the fuel, 240. Moment for the fuel is 12. Alright, let's see. Let me rework that one more time. So weight and balance. weight and moment 2060 for the weight, 9 that's right, 90.7 was the center of gravity. So this is not the moment. This is the center of gravity, 90.7. So for the fuel, moment 90.7. And then we add 240, moment 12. That gives us a new moment of 102.7 and gross weight of 2,300. So now we need to make sure we're still within limits. 102.7 and right at 300. So after adding the full max amount of fuel that we can, we are still right within limits for this aircraft.